Hello guys, welcome to MAT 240, and this time we have two sessions. As I mentioned before, we have 10654 and then we have 10659. So we have two sections and they are running on Tuesdays and Thursdays. So I'm going to use one section, which is 10654, to provide these videos, but everything will be the same for the other section. Now, if you look at your what we have already covered and sections that I provided lecture, you can see that in week 1 we have recorded lectures. So if you missed the class during week 1, so you can go through the lecture and be able to understand what we learned. So week 2, we started working with descriptive statistics, and we have a descriptive statistics lecture, and also that is the PowerPoint, and also we have recorded lecture which is based on descriptive statistics 1, the Excel file which is posted. So what you're supposed to do is to open that this Excel file, follow what we had, what we discussed in class, and once you are done, you can submit in week 2 if you are not in class during that week. Now, in week 3 also, we discussed about the descriptive stats, and we look at the more topics and sections of descriptive statistics, and we have notes posted, I'll say PowerPoints, and so we have actually 2 PowerPoints posted, and then we have Excel file which we normally worked on it, and then we have recorded lecture 1 and lecture 2. So if you can go through the lectures and follow the tutorial or follow how we worked on it, that will be fine. And so these two were our classwork. So if you can listen to the lectures and follow, and I believe we use this Excel file or the 2 Excel files are there. So once you are done following what we did in class, you should also post this as your classwork. That is for week number 3. Now, we don't have, so far we don't have a recorded lecture on week 4. So I'm going to record the lecture, which I may combine with week 5. And then we may have another one for week 6, which talks about binomial distribution. So in week 4, we introduced the concept of probability, and I'm going to show you the notes which we used, and we can go through the notes very briefly. And also I will use Excel file to show how did we work on it to respond to a number of questions. So in week 4, we learned about probability by understanding what is probability, and then we looked at the basic rules of probability. They are 3 or 4, and I'm going to show you. So we covered those basic rules to see how we can deal with the probability, and then we learn about probability distribution. What does it mean by probability distributions? And then in week 5, we started looking at probability distribution of discrete random variables. So if you can go to lecture 1, we learn about different characteristics of data, where we looked at a number of characteristics. And one of the characteristics of the numerical data is your data can be discrete or it can be continuous. And so when we are learning about probability, we will look at the probability distribution of discrete variable or discrete random variables. These are the numbers that we can count from 0, 1, 2, 3, 4, and so forth. They are whole numbers. So we'll look at how we can provide a probability to that kind of data. Data, or the variable that has data that is in discrete form. So we'll look at the discrete random variables, and we will look at a number of examples. One is the binomial distribution, which will be an example of the discrete random variables. And also we'll look at the exponential distribution and Poisson distribution. I'm sure that one is covered within this week 6, especially the Poisson distribution. I will discuss about that as well. And when we completed those sections in week 7, we had a midterm exam, which was followed by continuous random variables. And so from week 8, we started looking at distributions which are continuous. So we'll start looking at the continuous random variables, and then we focus on a number of distributions where we have learned about the z-test, t-test, and then we learn about sampling distribution and estimations, followed by hypothesis testing, and the last topic, or the next topic, will be regression analysis. So let me start with probability, which is week 4. So here I have notes which are also posted, and then I have Excel file where I'm going to create notes and show what was covered in class. And so we flip coin 3 times and see what are the chances of getting tails or heads. And so we can show the distribution. But before we go there, as I said, we need to understand what is probability. And so you can read the notes here. It talks about probability. And in this case, we can see definition, which is here. It says, what is probability? And we know probability is a chance of an event to occur, meaning that event will occur by chance. Or the other definition, we can say probability is the number between 0 and 1 that measures the likelihood that some event will occur. So using Excel, so we can say it's the number between 0, and I'm going to put 1 there so that we may have this middle section. So it is the number between 0 and 1 that measures the occurrence of an event to occur. So going back to the type or the characteristics of data, we saw that our data can be discrete or can be continuous. For discrete values, we looked at numbers that can be counted. We can count from 0 to a certain number. But for continuous, we look at the measurements. And with the measurements, we can see that we may not have just the whole numbers, but we can also have values within 2 discrete values. Take an example of 0 and 1. You can see that we have a lot of values in between if we consider decimal points. We may have a lot of values here. In fact, they are uncountable when we consider decimal points. So that said, probability are those numbers between 0 and 1 that measures the likelihood that some event will occur. And so numbers should be between 0 and 1. Since these values are uncountable, we can identify just the middle value. And our middle value will be 0.5. That's the halfway. So we can look at that 0.5, which is also significant in terms of probability. However, all I want you to know is the number between 0 and 1. That is probability. And those numbers, or any number between 0 and 1, will measure the likelihood of an event to occur. So it means that probability cannot go beyond 1. And also, probability value cannot go less than 0, meaning that there is no negative probability. And that's what is mentioned here in our notes. So now, normally in probability, we consider some events. And so here also in the notes, we are talking of an event. So let me show you how when we talk of an event, what does it mean? So here I can say let A be any event. Let A be any event, anything that can occur. So let's say rainfall is an event. Passing your exam is an event. Or doing a business is an event. Making profit is an event. So any event, sports, let's say, scoring a goal is an event, and so forth. So let A be any event. We can write probability of this event as follows. We can write probability of event A. So this one, we don't read it as PA, but we call it probability of event A. So an event with 0 probability, it means that that event will never occur. There is 0 chance of that event to occur. Also, an event with 1 probability, 100% probability, it means that that event will certainly occur. It will definitely occur. So our interest is not about a probability of 0 and probability of 1, because we know that with those 2 probabilities, an event will either occur or will not. It will definitely occur if the probability is 1, or it will not occur if it is 0. However, probability or an event with probability between 0 and 1, so that event involves uncertainty, meaning that there are some chances of occurrence and some chances of not occurring. So if let's say we have 0.5, so that means the chance of an event to occur, it is 50-50. We have 50% chance of the event to occur, and also there is another 50% of an event not to occur. So that's why we say the probability, or an event with probability or with probability value that is between 0 and 1, then it involves uncertainty. So the closer the probability is to 1, then the event is more likely to occur. The closer you get to 1 probability, an event is more likely to occur. And the closer the probability of an event is towards 0, the more likely it is that the event will not occur. So the next thing is for us to be able to express probability. So as I said, we can write probability as probability of an event. And so if our event is A, then we can write that event as probability of A, or probability of event A. Now, probability can be expressed in a number of ways, which are actually mentioned in our notes. One is decimal points, and that decimal point is 0 to 1 scale. As I said before, we have decimal points, decimal values from 0 to 1, which are uncountable. And so we can express probability by a decimal. So we can say probability of A equals or is 0.5, or it is any number with the decimal point. However, we can also express probability as a fraction. And in this case, we look at how many parts of a certain size there are. For example, 1/2, 3/4. So like this one here, we can say 1/2. And in this case, it is actually 0.5. And so it can be expressed in terms of fraction. But we can also express probability as percentage. So here we have 0, and in fact that can be 0%. So I can write 0% here. And this one, which is 1, it is actually 100%. So that means we multiply the decimal by 100. So if we multiply by 100 here, we're going to have 50%. And that's how we can actually express probability as well. But there are some other ways of expressing probability. For instance, we can express probability as an odd, also in ratio. And I think those are the main ways of expressing probability. But sometimes we are used to decimals and percentages. And so once you have any percentage, I want you to think also of a probability, not only just the percentage. Think about probability. If you have an event, we look at the probability of that event, and we can write it like this. And so we can say probability of an event A is either in terms of percentage or in terms of decimals, whichever way can be explained. So the next thing which I want you to know are the basic probability rules, which we have them in the notes. And our first probability rule is what we call complementary rule. In fact, here we are looking at just basic probability rules, which we are going to use in our class. So we have complementary rule, additional rule, and also we have conditional probability, and also we have multiplication rule. So we'll start with complementary rule. What does it mean by complementary rule? I'm going to use the example that we have here. Let A be any event, so we can write probability of A. But also we can write probability of not A. So we can look at something which is not A when we have an event or we don't have that event. We call probability of not A. So in this case, we can say probability of not A. That's how we can write this. Probability of not A. And we call that as complement of A. So in this case, we can add our probability. And so we have probability of event A plus probability of not A, which is complement of A. And so the answer here will be 1. When you add probability of an event plus the complement of that event, the answer will be, that means we have exhausted all the possibilities. Talk about rainfall. If our event is rainfall, so we say probability of having rain, and the opposite of that is probability of not having rain. If you add them, you'll get 1. In this case, we can do a number of mathematical manipulation, meaning that probability of A, 1, minus probability of not A. So let's say I have probability of not having A, and I have no idea about probability of A, and I know when you add them, you'll get 1. So it's easier to take 1 minus probability of not A, which is known, and so you can get probability of event. And the opposite is true. So we can say probability of not A. This one will also be same. We can say it is 1 minus probability of event A. So let's say if, for instance, probability of event A is, and I'm going to skip and go to this cell here. So let's say it is, since we know that probability of event A is 0.4, so we'll take 1 minus 0.4. So I'm going to put equal sign, click on 1 minus 0.4. And so probability of not A is actually 0.6. And in this case, if we go to addition here, probability of event A is 0.4 plus probability of not A is 0.6. So 0.4 plus 0.6 equals to 1. So the second rule is additional rule. There are two conditions which are important, and they are listed here. First of all, the probabilities should be mutually exclusive. That's one condition. And the second condition, they must be exhaustive. When we talk of mutually exclusive, it means if one of the events occur, then the other cannot occur. So we cannot have two outcomes in common. If we do, then we cannot add. That is what we call mutually exclusive. When one event occurs, then the other cannot occur. For instance, we are talking of having rain as our event. So probability of having rain and probability of not having rain, they are actually mutually exclusive. You cannot have rain and at the same time you don't have rain. It cannot happen. Either we are going to have rain or will not have rain. So for us to be able to add them, they should be mutually exclusive. And when we talk of mutually exhaustive, it means that the occurrence of one exhausts all possibilities. And when we add probabilities and exhaust all possibilities, so the answer will get 1. So let's consider events. Let's talk about two events. And so let A be any event, and also let B be any event. So we can write probability of A as probability of A, and also we can write probability of B as probability of B. So we're going to add these two events. And in this case, we're going to take probability of A plus probability of B. So they are mutually exclusive, meaning that probability of A is not the same as probability of B, and they don't occur at the same time, and they must be exhaustive. And so in this case, they will be equal to 1. So always when you add probabilities, they should sum up to 1. If there are some elements that are in A and also in B, they should be deducted. They should be removed. And the common elements we call joint. So what does it mean by joint probability? It is, we can write joint probability as follows. Probability of A and B. So to add our probabilities when we have elements that are common in A and B, so this is how we should add the two probabilities. It will be probability of A plus probability of B. And now we are going to minus what we have in common, that is probability of A and B. That's how we can actually add these two probabilities. We have to remove what is common in A and B. We can add a number of probabilities as long as they are mutually exclusive and mutually exhaustive. So the last one, or the third one, is the conditional probability rule. So I'm going to move to the other side. Let me move this way. So I'm going to start from here to write our notes. So the conditional probability is when one event depends on the other. So in this case, we are looking at the relationship between the events. So let's consider event A and event B. So let A be or can be any event, and at the same time let B be any event. It can be any event of your choice. And as we said, we can say probability of A and also probability of B. However, according to the conditional probability, we are going to see if A depends on B to occur, then we can write that condition as probability of A given B. Probability of A given B. That's how we can write the conditional probability. So, as I said, in this case, we are looking at events that are related, and especially when one event is a function of the other. So, for instance, if A is a function of B, in other words, if A depends on B to occur, then we can write a probability of A to occur given that B occurs. And in that case, we can write it that way. And so this probability has equation. We can write an equation for this. So it means, in this case, we are looking at probability of A and B. A and B is actually a what we call the joint probability, A and B. So they happen together or jointly, or they have elements that are common in each side. So it should be probability of A and B, which is the joint probability, divided by probability of B. So we can put the brackets in this case, divided by probability of B. We don't really need this. Let me remove it. So that is the formula for a conditional probability. That's how we can identify the conditional probability. If A is a function of B, then that means the conditional probability can be written as probability of A given B occurs, and we can express that as the joint probability of A and B divided by the probability of B. So let's consider an example to explain this. So let's look at the students. Let's say we have students, and students are interested in buying sodas. So we have Coke, and then we may have Fanta or Sprite, and there are some students who don't really drink soda, and so we can say none. And here we have either boys and we have girls. So we're going to look at their preferences. And so let's look at their total here, the total, and we'll look at the total here. So let's say we have a number of boys, let's say 25 boys, and we have just take the number of girls, let's say we have 30 girls and 25 boys. So the total here, let me highlight this so we can see it properly. Let me do this. I'm going to highlight that way, and also, okay, so we know that boys will drink, we have 25 or 25 boys, and also we have 30 girls. So the total number of this, I'm going to put equal sign to find the total number, and I'm going to click on 25 plus 30 and enter. So we have 55 in total number of boys and girls. So let's look at their preferences. Let's say about 3 boys, they don't drink any kind of soda. Let's say 10 boys drink soda, and let's say put any value there, like 6 will drink Fanta, the remainder will drink Sprite. So when you add them, they are 19. So I'm going to put equal sign here and click on 25th minus 19. This value here is 6. So that is for the boys. And remember, we are just assuming these values. So here we have girls, and we know that girls may love any soda. We can select any. And let me go with Sprite, that girls like Sprite. So I'm going to say about 12 will drink Sprite, and 3 probably. So let's not go with 3. Let's go with 2. 2 of them, they just take, they don't take soda. And let's put another value here. Let's go with 8. And so you can see we have 12 girls that drink Sprite, 2 none, and 8. So that means 22 students already. 12 plus 2 will be 14, plus 8 will be 22. And so let's see how many will take Fanta. So I'm going to put equal sign and click on 30 minus 22. And so we know that about 8 girls are drinking, they take Fanta. Now we need to find the total number of the boys and girls prefer Coke. So put equal sign there, and I'm going to click on this plus 8. So we know that about 18 boys and girls will prefer Coke. How about Sprite? So we can copy the formula that we put here. Let me repeat again. So all I'm going to do is go down here and drag to the right. So we have 14, and I can still use the same formula. Go to Sprite and also to none. Since we have formula here, we can copy that formula all the way to the right. If you add 18, 14, 18, and 5, you will get 55. And if you add these 2, you will get 55 as well. I'm going to copy and paste them here so I can be organized. And I'm going to remove this. And all I'm going to do here, just put equal sign and write sum, because we are going to add these 2, close the bracket. We have the answer. And I can do the same here, find the summation of these 2, close the bracket, and get 18. So exactly the same as what we did. That's what we have. Let me remove this. So we can actually provide probability in this case. And so all I can do is I'll copy all this and paste here. However, I'm going to remove these values. So I'm going to assign probability. You can see that here we have this total, and that total should be, if we assign probability, if we can add all this, they will sum up to 1. And how that will happen, it means first of all, I'm going to take each value here divided by the total, meaning that if, let's say, the number of boys who prefer Coke, they are 10 out of 55, and so I'm going to put equal sign here and click on 10 out of the total, which is 55, and enter. So you can see the probability here. We have changed this number into probability. How did we find it? It means that we look at how many boys took took Coke or prefer Coke out of the total. So we'll take 10 divided by 55, and so we get that. So we can actually copy this formula. Let me see. So we can copy the formula, but I would like to lock down this 55. We'll learn about how we can lock it down. So we can lock down here by pressing F4. So we can put the $sign on both sides of this column, which is M for me, this one here. So we lock it down, and I'm going to enter, and in this case everything will divide by the 55, and so I can bring it down, bring it to the sideway, and also I'll bring it way down. All I just did is to copy the formulas. Let me repeat this to help you understand what I was actually doing. So remember, all we need to do is to find the probabilities for these preferences. And so we look at the first preference, which is for the boys that drink Coke, and we'll take 10 out of 55, 8 out of 55, 18 out of 55, 25th out of 55, 30 out of 55. All this will occur out of the total. So in that case, when I click here, it means we'll take 10 out of 55. So it will be this value divided by this value here. And all we did was to lock down this particular value, meaning that all other values, if we copy the formula, will refer to the 55. So if we can enter, we can copy the formula by dragging down. And if you can see here, we have 0.18182 and 0.14545. If you can add these two, you will get this value. And so I can do the same. Let me put up to this point, sorry. So I'll do the same by going the other direction, which will take this, we'll add all this, and then we get this total. And this happens when we find the probability of this value divided by 55, and also the probability of Sprite the same and none as well. So if you click there, you can see 3 divided by 55. That will give us the probability for none. So no, they drink nothing. And all I did also was to do the same for the girls. So I'm going to copy the formula. sorry about that. Let me copy the formula for the total. So it is the same. You can also do the same for the girls. So you can see 55 here, 55 divided by the 55, which will give us 1. And remember, when we add probability, we will get the total, that is 1. And that's what we got here. Okay? So we have changed these preferences to probabilities. And so we can say there is 0.18182 chance that a boy will drink Coke. There is also 0.14545 chance that if a girl walks in, they will buy Coke. And the total probability will be that one. And so we can see for the Fanta, we have 0.10909 chance that if a boy buys soda, they will buy Fanta. And there is 0.14545 chance that a girl will buy Fanta. And we can add the two probabilities. And so when we add this total, the total for Coke, that means there is 0.32727 chance that Coke will be available. There is also 0.25 chance that Fanta will be available or will be purchased, where 0.10909 chance will go for boys, out to boys, and 0.14545 will be for girls. And it will give us the total of 0.25455. And so the same. Now, when you add the total of Coke, Fanta, Sprite, and Nan, those chances are exhaustive. And so when we add them, we'll get 1. And each one of these are independent. They are exclusive. So that's how we can actually turn this into probabilities. So now let's go back to our conditional probability. But before we go to the conditional probability, we need to find or to understand these values. So here you can see it. We have this probability of Coke and boys. That probability. Boys and Coke, that's the joint probability. This is also a joint probability between Coke and girls, probability or joint probability between Fanta and girls, and also joint probability between Fanta and boys. So the same with Sprite and Nan. So these are actually joint probabilities. And we can add them on their own, so they'll give us the total number of boys. So we have 45 boys, the number of boys customers, or the chance of, I'll say, boys will constitute 45% and girls will constitute 55% in this case. And so we have 100%. So let's go to the conditional probability. So it says, what is the, so talk about the conditional probability, and in this case we say probability of A given B. And we know the formula. So my question here is, what is the chance that if the boy walks in, or the boy would like to buy soda, that boy will buy soda if Coke is available? What is the probability, or what is the chance that the boy will buy soda given that Coke is available? So very quickly you can mention about this one here, which is the joint probability, but that is not true. We are talking of a condition here. That what is the condition, or what is the condition that, what is the chance that a boy will buy soda or will buy soda if Coke is available? So that means Coke is a condition. If we have Coke, what is the chance that the customer, who is a boy, will buy Coke or will buy soda if just Coke is available? That's what we say here. And remember, we know the formula. So let's put our formula here. So I'm going to write here equals and skip, go to the lone cell where we can do our operations. So remember, it should be probability of A and B. So that's the joint probability. And that will be divided by the probability of B. B is the condition. So in this case, let me write those requirements. So what are the chances that the boy will buy soda if Coke is available? So Coke is our condition. So in this case, A will be boy and B is Coke. So we can follow these calculations and we'll understand the chances that the boy will buy soda if Coke is available. So in this case, we're looking at probability of a boy given Coke. So that will be equal. So now we're going to look at probability of boy and Coke divided by probability of Coke. So once we know this, we will find the probability of a boy and Coke, which is this one here. So I'm going to put equal sign there, and I'm going to click on the probability of a boy and Coke, and I'm going to divide by the probability of Coke. So the probability of Coke is the one that goes with boys and the other one that goes with the girls, and so the total chance of having Coke is that one here. If you can enter, you will see it is 0.56. So let me make this wide. So let's look at the number of examples. So what are the chances that Coke will be purchased if customer is a girl? What are the chances that Coke will be purchased if the customer is a girl? So in this case, you can see that our condition is a girl. And we're going to look at the chance that the Coke will be purchased. And so in this case, we'll look at A to be Coke, and B, in this case, will be a girl. And so if we follow this formula, you will go with, let's write it down here as we did before. It is the probability of Coke given girl, which should be equal to the probability of Coke and girl, close the bracket, divided by probability of a girl. That is the condition. So here we have a girl. So now we're going to look at the joint probability. In this case, the joint probability between Coke and a girl is this one here, Coke and girls. So that's the one, we have clicked on it. So in this case, let's just do it here. Okay, here, put equal sign. We are going to click on the probability of Coke and girl. So that one divided by the condition, which is the girl. So we're going to look at the probability of a girl, that one here. If you can enter, you can see it is 0.2667. So all I want you to do is the following. What are the chances that no soda will be purchased given the customer is a girl? So what are the chances that no soda will be purchased given the customer is a girl? So we can go up here, and we know that according to this formula, the probability of A given B. So in this case, our condition is a girl. So when the soda is not purchased, here we go with none. So none soda will be purchased. So the joint probability between none and girls will be this one divided by the total number of girls, which will be that one. So let me go down here. So I'll say probability of no soda divided by, given the customer is a girl. So close the bracket, divided by probability. So let me go down here, see what I wrote here. So I was supposed to write probability here, probability of having a girl. So probability of girl, that's how this should read. And so what are the chances that no soda will be purchased given that the customer is a girl? So probability, so about this, so it should be probability of no soda and a girl, and probability of a girl. So no soda, we can put equal sign here. The joint probability between none and a girl is this one divided by the condition, which is probability of a girl, this one here, and enter. So we could do the opposite. Let's say we could say, what are the chances that no soda will be purchased? What is the chance that if the customer is a girl, will not buy soda? If the customer is a girl, that she will not buy soda. So we go with a girl and soda, and our condition is they will not buy soda, so the none will be considered. Now, if you understand the concept, you can do all this very easy. So try to do some practices for the conditional probabilities.